This is Josh White with JW Math Tutoring. Today's video is going to cover Bluebook Practice Test 5, the Digital SAT Math Section Module 1. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
All right, just before I get started on Digital SAT Practice Test 5, the Math Module 1 from the Bluebook app, two things just to mention. First, if you like this video, please, of course, do give it a thumbs up, subscribe to my channel, sign up for notifications. And second, this video will most likely go past the allotted time for this module. That's because I like to show multiple ways to solve the questions whenever applicable. So just be aware that I might not complete this in the required time, but that's because I might show 2 or even 3 different ways to solve some of the problems. All right, so getting started here with question number 1. This is basically a linear function that they're talking about, and I basically want 25. It says here 25 calories per pound, and they tell you the weight is X pounds. So that's a clue, that's a hint that 25 is going to be multiplied by X. However, they also want an additional 11 calories, so you're going to need a plus 11 on top of that as well. So the correct answer for this one is just going to be letter D, and that's it. Next, here we have one that's just a basic unit conversion, or you could also do it as a proportion. Basically, you have this camera, which is at a depth of 39 fathoms. Okay, and they want to know the depth in feet. So if you do basically like factor label, you may have learned about if you're taking chemistry, you can just take the 39 fathoms and multiply that by the conversion factor, which is 1 fathom on the bottom and 6 feet on the top. So now these units will cancel out. Just multiply 39 times 6, and we get 234. So correct answer for this one is just going to be letter A. Next, we have a set of parallel lines here. Although technically X and 145, like the fact that the lines are parallel technically doesn't really matter when it comes to these two, because these are just vertical angles. So this angle is also going to be 145 degrees. So correct answer for this one is just letter C. Next up, we have another linear function, and basically here they're giving you the y value of 58, and they want to know what the x value is. So essentially what you're doing is you're just plugging in 58 for f of x and then solving that equation for x. So you just subtract 14 on both sides and then just divide by 4. X is going to be 11. So 11 games can be played for this, total cost. Now, I will also mention that you can do this in Desmos as well. So all you would do is you would just graph y equals 14. There's multiple ways you could do it. You could graph y equals 14 plus 4x, and then you could graph also y equals 58, and you could see where do those two lines intersect. Okay, they intersect right here, and the x value of this point, which is 11, that's your answer. That's what you want. Or you could also technically do it this way. Just type in the whole equation and then see what the value of the x-intercept here is, which is 11. So that method will work as well. So we get the same answer of positive 11. Next up, here you have an equation, and they want to know what x is minus 7 is. So the way they're intending for you to solve this is to just factor the 4 out on the left side, because if you do that, you're left with x minus 7, and then you can just divide by 4, and you would get x minus 7 equals negative 6. So you would get the correct answer of C. However, if you don't see that, it's fine. You can just go ahead and solve. 4x is going to equal 4 because you add 28 to both sides and then divide by 4. So x is 1. You just have to remember they want x minus 7. 1 minus 7 is negative 6. So you get the same answer, either way how you do it. Next up, we have a question about basically a food order and a tip amount, which is just a percentage. So really, all you're doing here is you're taking 20% of $50. So that's just 0.20 times the $50 to get the tip amount, and that just comes out to $10. So the correct answer for this one is going to be just $10. And I just want to highlight real quickly in Desmos, you can actually just type, for example, like 20% of 50, and it'll just give you 10, and there's your answer. Next, question number 7. Here we have a table with the number of eggs for various turtles. They add some eggs to this. They add one value to this table. So what's going to happen to the mean, basically, once you do this? Or how is the mean going to compare from the original to the new set of data? So here's a theoretical explanation. Notice all of these numbers right here are between 139 to 149. Okay, so the mean of the original is going to be somewhere between 139 to 149. But now for the new data set, like you're adding in a number 121, which is lower than all of them. And you can see it's a pretty large outlier. It's 18 less than the smallest number. So the mean is going to go down because you're adding a number which is guaranteed to be smaller than the mean of the original data set. Therefore, the mean of the original data set is greater than the mean of the new. So the correct answer for this one is going to be A. But I will also show you that we can just go into Desmos and you can just quickly calculate the mean of the two things. Okay, so for the first one we have 143.2. So, I would just jot that down. And now all I have to do is add the 121. Okay, now it's 139.5. So we can clearly see that the mean of the original here is greater than the mean of the new. All right, and you can just, again, calculate that, figure that out in Desmos, just if you don't understand the theory behind it. Next up, question number 8, we have a linear inequality, which is graphed. So a couple different ways you could do this. First of all, notice that this line has a negative slope. Therefore, we can get rid of answer choice A because that is a positive slope, and answer choice C. Again, that has a positive slope or a positive number in front of the x. So we're down to these two. So now at this point, you could just go through and you could pick a test point. And so, for example, 0, 0 works, i.e. it is shaded where 0, 0 is at the origin. So you're looking for the inequality that is true when you plug in 0 and 0. So for B, you would get 0 greater than -1 minus 0. Or in other words, 0 is less than -1. Is that true? No, it is false. 0 is greater than -1. And then if we do the same thing down here, this is going to be the one that's true. It's going to be the opposite. 0 greater than -1. Yes, that is true. So the correct answer is going to be letter D. However, I will show you that, again, you could do this one entirely in Desmos. You could go through, and even if you didn't recognize the parts about the slope, you could graph this. Okay, does this match the picture? Nope. So now let's look at this one. Does this match the picture? Nope. Okay, let's change the sign. Notice just by changing the sign and nothing else, I already ended up at D. So you could see this is clearly the right answer. But if you wanted to try C as well, you can see, yeah, it's got the wrong slope. That's not it. So you could easily do this one, again, entirely in Desmos. All right, next up, number 9. Here we just have two expressions that are being combined, technically subtracted. So we're just going to combine the like terms here. So 8x cubed minus x cubed, that's going to give me 7x cubed. So those are done. And then notice it's 8 minus -2. That's the same as 8 plus 2, which is 10. So correct answer on this one is going to be B. Again, I will show you just real quickly. You could also do this one in Desmos as well. Basically, what you would do is you would type in the first expression. Okay, and you get basically you get some cubic graph like this. Then you go through the answer choices and you see which one matches exactly or identically, okay? So notice this one does not match identically. It's pretty close, but in the middle, it's not completely overlapping. Then you go to choice B. Notice that when I changed just the first term there, I technically had answer choice D, which did not match. Back, just you see it doesn't match. But now you can see here, excuse me, clearly these two are the same. You highlight one, you take one away, same exact graph. So that's basically how you can match two expressions in Desmos to get the correct answer. All right, next up, number 10, we have a line going through 2 points. So first I'll show you how you would do this the traditional way, and then I'll show you how to do it very quickly in Desmos. Now, a couple things. First, I would find the slope. So I would do 17 minus 9 and then over 1 minus 0. So slope is just going to be 8 over 1. Right off the bat, I know it has to be answer choice D because that is the only line with the slope of 8. And also notice one of these points, 0, 9, this is the y-intercept. So 9 is the b value. So I know it has to be answer choice D, based on that as well. But just to show you, here's how you could do it in Desmos. We just make a table, and we put both points in the table, and then we just do a linear regression. All right, slope is 8, y-intercept is 9. Which of these has a slope of 8 and a y-intercept of 9? Well, it's answer choice D. And that's it. Next up, here we have a student-produced response question, and they want to know the solution to this equation. So if you want to do this by hand, technically it's actually not a lot of work, because if you just add 7 to both sides, you get d minus 30 times d plus 30 equals 0. So this equation is already factored. In other words, you basically know that there's two solutions to this. One of them is going to be positive 30, which comes from here, and the other is going to be negative 30. So what is one solution? Well, you can just type in 30. Now, again, you could also, if you don't recognize that, if you get confused by that, you can just go straight to Desmos and do it this way. So again, the way I like to do this is I like to graph y equals the left side. Notice I'm going to change just the d to an x. Then I'm going to graph the right side. Now I have to zoom out because originally I didn't see any of the, I didn't see any of the first graph when I was zoom in here. But I zoom out, now I see both things. Okay, so I'm looking for the intersection points when I use this method. So here's one, x is negative 30. Here's the other one, x is positive 30. So this is an alternate way you could do it. Again, you could also type in just the entire thing on one line, and then you're looking for the x-intercepts of the vertical lines that appear. So again, negative 30 and positive 30. However you do it, Desmos can solve this one as well. All right, next up we have basically a linear equation, with two variables here. And this is just basically an interpretation of a linear function. So there's two different size containers of blueberries. The total sales amount is this, dollar figure on the right. So basically on the left, you have like total dollars from small containers and then total dollars from large containers. So the total dollars are going to be, the price of a container times the number of containers sold. And that's what the X and the Y stand for. Number of large containers for Y, number of smaller containers for X. So what is the price? Well, the price is for the small is going to be this number right here. It's just the 4.51 that you multiply by the number of containers sold to get the total dollar value. Next, we have an exponential function here. And they just want to know, essentially, for this, it's like knowing what the y-intercept is. In other words, when T is equal to 0 because it says what's the number of particles when it's at the surface of the sample? Well, at the surface would mean 0 millimeters below the surface. So we're just plugging in t as 0, and it's just, and if you are familiar with exponential functions, you should recognize the initial value is just this number out front here, because 0 over 12 is 0. 0.5 to the 0, or any number to the 0 power, is just 1, and 500 times 1 is 500. So this one's going to be 500, and that's it. No other work to do. Okay, next we have a rational function. Let's see if I can. It's going to be real small just to see all the answer choices, so I guess I won't zoom out that much on it. Okay, and they want to know which of the following is the graph of this function plus 5. Okay, so um, easiest way to do this, I think, is to pick a point on this graph, and I'm going to pick this point right here, which is at 9 comma 1. And now on our answer choices, we're looking for this to be shifted up 5 units. So this is going to turn into 9 comma 6. So which of these answer choices go through the point 9 comma 6? Not A, 9 6 would be, up here. Not B, not C. So you can see by process of elimination, it's going to be D, right here, 9 comma 6. And again, you could pick other points too, but generally you want to pick a point that's, exactly right on an X and a Y integer value for the coordinates of it. So the correct answer for this one is going to be letter D. Now, here's an alternate method you could use to solve this problem entirely in Desmos. So all I'm going to do is I'm going to take the graph of this function, highlight some points from it, and then take those points, do a regression in Desmos to get the actual equation of the graph that we're given for f of x, and then just shift f of x up by 5 and see which graph from the answer choices matches my new graph. So it sounds like a lot, but it honestly doesn't end up taking that long. So here's my first point, 1 comma 9. I'm also going to use this point right here, 3 comma 3, and then there's another point right here, 9 comma 1. Okay, so those points are all basically at the intersection of integer values. So I just enter those in. All right, now I'll go ahead and do a basic regression for a rational function. So basic form is just going to look like this: some number on the top over an x, and it could and plus or minus a number. So the a and b values are the two values I'm looking for. So this gives me an a value of 9, so there's a 9 on top, and b is just 0. So this function that's graphed here on the screen is just really 9 over x. All right, so now I'll just go ahead and graph that. But I'm going to define it, set it equal to f of x instead of y, and the whole reason is because now I can easily do a translation. So here's the original function now. The new function, the answer choices are this function just with a plus 5. All right, so I'll turn off the original. Now, when I'm looking at just this part on my screen here, which of these answer choices match? Well, obviously not A. A goes way down here to -4, okay? That's wrong. Looking at B, this goes down and gets real flat close to 0 in terms of its y value. That's wrong. C, this goes down and gets real flat close to 1. Okay, that's obviously wrong. By process of elimination, it's going to be D. And you can also see this one goes down and gets real flat close to 6, although technically it does actually approach 5, if you go out far enough. But D is going to be the correct answer. And again, that's how we can do this entire problem in Desmos, just by doing a rational function regression. Now, for question number 15, you just have a formula relating a bunch of different letters here. And so they're just asking you to rearrange this and solve it. So we want to solve this for c. Technically, the first thing you can do is you can divide both sides by n to basically get rid of it. And then you can subtract 19. So we have p over n minus 19. Now that's equal to negative c, but we want positive c, of course. So now we could just multiply by negative 1. That's going to flip the negative 19 to positive, and it's going to take this p over n and make it negative. Now, when we look at the answer choices, we can clearly see that D, matches this perfectly. Now, here's an alternate method you could use to solve this problem. It's basically the technique of picking numbers, and I'm going to use Desmos to help expedite the process and do it in basically a much quicker and more efficient manner. So what I'm going to do is first type in the original formula, and I'm going to define some values for n and c. So let's say n is equal to 3, and we said c equal to 2. All right, and now that gives us p equals 51. All right, so those are basically the numbers I picked. P is 51, n is 3, c is equal to 2. All right, now what I'm going to do is go through the answer choices, plugging in p and n, and seeing which of those values gives me um, c value equal to 2. So first, let me just clear this off. First answer choice. Now, T I already said was 51. You just jot that down. N I already said was 3. Okay, is C equal to 2 here? No, it is not. So now let's try answer choice B. Change that to a minus. Does C equal 2? Nope, that's wrong. Okay, let's now try answer choice C. Does C equal 2? No, it is wrong. So by process of elimination, it's going to be D, but we can also just confirm that when we type in the formula for D, we get C equal to 2. That is the correct answer. So again, the strategy used here, the overall process was picking numbers, except I used the Desmos calculator to evaluate the formulas, basically doing it in a much quicker manner than it would be plugging into a handheld calculator. All right, next up we have question number 16. We have a box, and we know that basically the length of each edge is 29. We also know it's in the shape of a square, and they want to know the surface area. So basically, if you think about the picture, essentially what we're saying is this is 29, this is 29, this is 29. Okay? So notice the area of each face of the box is just going to be 29 squared, because it's the length and width and height are all 29. So however you do it, front, back, left, right, top, bottom, they're all 29 by 29. So each face is 29, and there are 5 of them. There is no face on the top. So that's why I'm multiplying by 5 and not by 6. We have front, back, left, right, and bottom only. There's no top because it says it does not have a lid. So you take 29, you square it, you multiply it by 5, and that's just 4205. That's going to be the total surface area of this box. All right, next up we have an absolute value equation. So they want the sum of the solutions. So you can solve this one by hand, but I'll also show you how to do it in Desmos. First thing I would do is I would isolate the absolute value expression. So I would subtract 45 on both sides. Then you're going to get two equations. X minus 9 equals 18. X minus 9 equals negative 18. X is going to equal 27. Or X is going to equal negative 9. Now be careful, they want the sum of these two values. So 27 plus negative 9 is equal to, should be 18. So correct answer for this one is going to be 18. Here's how you can get in Desmos. Probably will be quicker. So again, the method I like to use is I like to type y equals the left side and y equals the right side. And then I look for the intersection. Okay, so I have two intersection points. One is here at -9, one is here at 27. So we just add those two together and we get 18. Same answer we got, solving it by hand. Next up, number 18. So this one, there are multiple ways you could do it. I mean, if you are, excuse me, familiar with the unit circle, you could do it that way. Um, but honestly, what I think the easiest way to do this is first make sure you're in radians. Click the wrench icon and make sure radians is selected. Do the tan of 92 times pi divided by 3. Doesn't matter if it's the whole thing's on top or, whatever's. Um, and now you get this answer. Now what we have to do is figure out which answer corresponds to this. So obviously it's not C and D because those are positive numbers. It's got to be A or B. So, okay, let's check. Let's check A. Does that match? Yep. So that's the correct answer, letter A. All right, for this question, here you have you have two expressions that are being added together. They want to know which expression here is equivalent to it. So if you go ahead and get a common denominator, combine them into one expression, basically one fraction, just multiply this by k over itself, and you're going to be adding 42a plus 42ak squared all over k. Notice this doesn't quite match, and the reason is because they factored out a common factor. They factored out the 42a on top, and you're left with 1 plus k squared. And in addition to that, they switched the order of the terms because addition is commutative. So they just rewrote this as k squared plus 1. So correct answer here is going to be letter D. But there are other ways you could get this as well. So if we go into Desmos, first of all, you could do picking. One way to do it is picking numbers, but we go into Desmos, and I'm going to graph. Let's see here. The first thing. Actually, I'm not going to graph it. I'm going to do an expression. I'm going to add some sliders. I'll just move them to whatever random value here. Okay. Now I'm going to do the same thing with the answer choices. And I'm going to see which answer choice has the same value as this top one. So that one is obviously not correct. Checking answer choice B, 84ak squared over k. Okay, that doesn't match. Not correct. 42a times k plus. Checking answer choice C. That is not correct. So, okay, process of elimination, it has to be D, but just to confirm, notice we have the same exact value. And like as you move this, they will remain the same, regardless of what numbers. I mean, just obviously k has to be greater than 0, but again, these numbers will be identical. Therefore, correct answer is letter D. Next up, we have question number 20. Here we have the graph of a circle given in standard form. And they tell us that some point lies on the circle, and they want to know which of the following is a possible value for A. So, okay, a couple different ways you could figure this out. First of all, the center of this circle is at -419. Okay, notice that they're asking for A, which is the x value, x coordinate. So, also notice the radius of this circle is the square root of 121, which is 11. So that means like you have the center at -4 here, and the radius goes out, up to 11 units to the right. So it's like this is a distance of 11. So that would put you at +7, -4 plus 11. And then also 11 units to the left, which would be -4 minus 11. Okay, so -15. So all the x values are going to be between -15 to 7. So Which of these values up here are between negative 15 and positive 7 for an x-coordinate? Not that, not that, not that. So correct answer has to be letter B. Now, I will also show you, you could easily do this one in Desmos as well. So if you go ahead, graph the circle, you'll be able to easily see um, which ones are on the circle, which ones could be on the circle, and which ones cannot be. Okay, so here's our circle. Zoom in a little bit. So now what I'm going to do is I'm going to pick the x values for the answer choices, and I'll just give them the same y value as the center. So is this point on the circle? No. I mean, can it be on the circle? You know, you move it up or down at all? No, it's outside of it, clearly. And then if you do this one, now it's not on the circle, but if I shifted it up to like somewhere right around here, 23 point whatever, notice it could be, you know, so it's possible. And the other two, you're going to see it's not possible. This is outside the circle, clearly, and same thing with the 19, you know, way over here. So this is just confirmation visually how you can see what's going on, that it has to be answer choice B. All right, next up, question number 21. We have a rectangular prism, and we know that its height is 9 inches. So let me just get a rough sketch. What's going on here? Okay, the the base is x inches. Excuse me, the length of the length on the base is x, and it tells us it's 7 inches more than the width. Okay, so this is what I'm labeling the length, and then this other side would be the width. So what you have to realize here is that, like, since the length, which is just x, is 7 more than the width, an alternate way to think about that is the width is 7 inches less than the length. So that's why the width is going to be x minus 7. So correct answer for this one is going to be just 9, the height, times x, the length, times x minus 7. So just letter D right here. Now, alternate way you could do this is let's try picking numbers, okay? So we know height is 9. Let's say the length is 10, okay? They tell us the length is 7 inches more than the width. So 10 is 7 more than, well, 3. So what does the volume for this come out to? Looks like 90 times 10, or excuse me, 9 times 10, 90 times 3, 270. Okay, so now we just run through the answer choices, and I would probably go to Desmos, or if you have your handheld calculator, you can do it there, and just plug them in and see what you get. So notice here, okay, technically, just to make a note, the length, the 10, this is what I designated as x. Okay, so the 10 is the value that's being plugged in for the x in all of these formulas. So first one, we got 10 times 10 plus 9 times 10 plus 7. Okay, no. Next one, we've got 10 times 10 plus 9 times 10 minus 7. Is that 270? Nope. All right, let's clear this whole thing out. 9 times 10 now times 10 plus 7. Is that 270? Nope. Now what about if we do this? Yes, we get 270. So this is an alternate way you could solve this just by using picking numbers. All right, last question from practice test 5, the math module 1. So here you're given some information about this function. Okay, it's a radical function. A and b are constants. That means they're just numbers. And they tell you it passes through the point negative 24, 0, and that f of 20. Okay, which of the following must be true? So there's a couple ways you could do this. First, I'll just go through kind of visually and show you how you can figure it out, and then I'll show you also in Desmos just how you can confirm that. So it passes through negative 24, 0. So let's just say right over here, okay, here is negative 24, 0. So It also says that f of 24, so that would be like over here, is less than 0. So that means over here, like where x is 24, it's going to have a negative y value. Okay, so notice that means it's going to go down like this. Okay, just based on those two pieces of information. So, which of the following must be true? F of 0 equals 24. Okay, is the y-intercept at positive 24? No, clearly not. It's going to be some like negative number, so we can get rid of that. What about the y-intercept being negative 24? It's possible. We don't know exactly yet, so we'll keep it for now, but then let's look at C and D. Okay, A must be greater than B and A must be less than B. So if you're familiar with square root functions, like the number in front here, the A, basically if it's positive in a square root function, it's going to open up like this. If A is negative, it will open down. It's reflected across the x-axis. So A here has to be a negative number. B also is going to be a positive number, and we can actually figure out what the exact value is because if you plug in like negative 24 for x and you set that equal to 0, okay, so you have 0 equals a square root negative 24 divided by b. Okay, so if you just divide both sides by a, notice that the 0 on the left side just stays, and on the right side you have square root of negative 24 plus b. Square both sides, you get 0 equals negative 24 plus b because 0 squared is just 0. Just write that in here. And now if you solve this for b, okay, in this specific problem, b has to equal 24. So a negative number, a, is always going to be less than b, which has to be positive 24. So the correct answer for this one is going to be letter D. Like, it's possible that the y-intercept is negative 24, but it doesn't have to be that, based on the specific values of A and B. Here's how you could do this in Desmos, though, just to confirm it. Okay, so we have you put in a table here. I'm going to put in the negative 24, 0, and I'm going to put just a negative, just a random value here with the f of 24 point. And then I'm going to do a regression. Okay, so what I did is I did a table with 2 points. The first point is the negative 24, 0 point. The second point is the f of 24 less than 0. So I just picked some random negative number here. And now notice it gives us values for A and B. And so now you could just go through all the answer choices and confirm. Is f of 0 24? No. Is f of 0 negative 24? No. It looks like for this one specific example, f of 0 is negative 7.701. So that does not have to be true. And then for now, you can easily look at it. Well, A is less than B. Negative 1.44 is less than 24. So the correct answer is D. And again, you could pick different numbers here. You could make this negative 20. You could make this, negative 2. However it works out, you're going to get that D is the answer that is correct. All right. So that was, again, Digital SAT Practice Test 5, Math Section Module 1. If you have any questions or comments, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications, and also be on the lookout for the videos covering Module 2A and 2B, the 2-second modules for this exact same test.